In 2016, India signed a massive 8.7 billion deal for 36 Rafale fighter jets. But there was a secret item on India's wish list that France refused to sell. It was the technology behind gallium nitride chips. Why France refused? Because these aren't just chips, they are the super brains of modern warfare. France said it was a non-starter, too sensitive, and too advanced. They thought that without their help, India's radar and missile program would remain a generation behind. But they were wrong. Fast forward to February 2026, India hasn't just built these chips, it has cracked a secret code that only 5 other nations on the earth possess. Today we look at how a no from the West ignited a silent revolution in Indian laboratories. To understand the victory, you have to understand the science. For decades, silicon was a king. But silicon has a limit. It melts under high heat and slows down at high frequencies. But here enters the gallium nitride, which is a wide bandgap semiconductor. In simple words, it is silicon on steroids. The gallium nitride chips, they can switch power 3 times faster than traditional silicon and can operate in temperatures up to 1000 degrees Celsius. Also, these chips they can handle voltages that would vaporize a normal chip. When France refused to transfer gallium nitride tech during the Rafale offset, the DRDO did not argue. They went to work, led by the Solid State Physics Laboratory, that is SSPL in Delhi, and GAETEC in Hyderabad. Indian scientists they spent a decade in the trenches of molecular engineering. They followed a legacy started by Dr. APJ Abdul Kalam, who always insisted that India must own the materials of the future and not just the machines. By the early 2026, the lab results became reality. India successfully developed indigenous gallium nitride monolithic microwave integrated circuits. These chips are now deployed ready, but what does that actually mean? These chips they allow the Tejas Mk2 and upgraded Sukhoi 30 Mki to see further, track more targets, and resist enemy jamming better than almost any jet in the sky. In the final seconds of a missile's flight, these chips they provide the lightning fast processing needed to hit a maneuvering target. These chips are already powering India's reset satellites, surviving the brutal radiations of the space. India has officially joined the Elite 6, that is, the nations that have mastered indigenous gallium nitride technology for high-end military and aerospace use. These are the US, France, Russia, Germany, South Korea, and China. And now India joins it. But the gallium nitride isn't just for war, it's about to change your daily life. At the Indian Institute of Sciences, Bangalore, researchers at Center for Nanoscience and Engineering, they have achieved something even more difficult. It is gallium nitride on silicon. The traditional gallium nitride is grown on expensive crystals, and IISc found a way to grow it on a cheap silicon wafers. In 2025, they demonstrated an 8-watt power transistor at 10 GHz developed entirely in-house. This is why companies like Navitas and Cyient Semiconductors, they have partnered in late 2025 to build India's first gallium nitride ecosystem. While the military uses gallium nitride to win wars, common public will use gallium nitride to save time and battery. In case of electronic vehicles, it will charge faster and go 15% further on the same battery. It will also affect the 5G and 6G phones. Gallium nitride is a secret to 5G and 6G because it stays cool while data flies. It generates significantly less heat, allowing your phone to maintain peak download speeds without throttling. By slashing energy waste, these chips turn your device into a high-frequency powerhouse, delivering lightning-fast downloads in a cooler, thinner frame. The Indian government is doubling down the budget 2026. They launched the Indian Semiconductor Mission 2.0 with a fresh 40,000 crore focus on complex semiconductors. The goal has shifted, and India doesn't just want to be the world's back office for chip design, it wants the intellectual property. By owning the gallium nitride patents, India ensures that no foreign nation can ever choke its supply chain again. The story of India's gallium nitride chip is a reminder. Strength doesn't come from what you can buy, it comes from what you can build when everyone else says no. India is no longer just a consumer in the silicon age, it is a creator in the gallium nitride era. So, what do you think? Can India become the global hub for power semiconductors by 2030? Let us know your thoughts in the comments below.